2.3 limit laws. Suppose that c is a constant and the limit as x approaches a of f of x and the limit as x approaches a of g of x exists. Then, if you have two limits that are in brackets together, you can rewrite them as added out, just like function notation, right? Just like when we did operations of functions in 30-1, same thing. So if you have addition together, you can write them out separately. If you have subtraction together, you can write them out separately. If you have a coefficient in front of the f of x, it's not going to affect the limit because the coefficient is just a number that you're multiplying by. So you can take the coefficient completely out of the limit and just find the limit on the function f of x and then multiply the limit by it at the end as an end step. Multiplication you can separate, division you can separate. So really this coefficient one is the one that people don't notice as much, but if it has a coefficient in the limit, you can take that coefficient, that c value, and bring it out and then calculate the limit. Okay? So let's look at example 1. We're going to look at some graphs first and then we're going to do some actual algebra. So use the limit laws and the graphs of f and g to evaluate the following limits if they exist. Yo. Yes. So, if we look at this one, the limit as x approaches -2 of f of x plus 5 g of x. We could write this out in two steps. You can go the limit as x approaches -2 of f of x plus the limit as x approaches to -2, of 5 g of x. But instead of having the 5 in there, where can I put the 5? Out front. Kind of like a log, really. And take it out there. Because what's 5g of x? I don't know, right? In the graph. But I do know what the limit as x approaches -2 of g of x is. So I just take that 5 and bring it out front and multiply it in after I get the limit. So the limit is x approaches -2 of f of x. So I go to -2, f is this one. So I go to -2, it's approaching what? 1. From both sides? Left and right? Yeah, so it is 1. Plus 5 times, limit is x approaching -2 of g of x. So I go to -2. From the left, it's approaching -1. From the right, it's approaching -1. So the limit as x approaches -2 of g of x is -1. So it's going to be 1 minus 5, which is -4. You try B and C. So this one is the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. The limit is x approaches 1 of f of x. I go to 1. From the left, it's approaching 1, or 2, sorry. From the right, it's approaching 2. So it's going to be 2 times g at 1. So g at 1 from the left, it's approaching -2. From the right, it's approaching -1. So the limit at 1 does not exist. So the answer does not exist. Then we have the limit as x approaches 2 of f of x. So as we're approaching 2 of f of x, from the left and from the right, it looks like 1.3 or something. So you're going to get the limit as x approaches 2 of f of x divided by the limit as x approaches 2 of g of x. This one's going to be like 1.3, let's say. And then g, it's approaching what? 0. What happens when I divide by 0? It's undefined. Example 2, you guys give her. So I'm going to get the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. So if I approach 2 of f, I'm approaching 2 from the left, 2 from the right, so it's 2. plus, as I approach 2 on G, I'm approaching 0 and 0, so it's going to be 0. 2 plus 0 is 2. And this is going to be addition. So the limit as x approaches 1 of f of x plus the limit as x approaches 1 of g of x. So as I approach 1 from the left and 1 from the right, I'm approaching 1. As I approach 1 from the left and 1 from the right, as 1 from the left I'm approaching 2, 1 from the right I'm approaching 1. So it does not exist. So it does not exist. The limit as x approaches 0 of f of x times the limit as x approaches 0 of g of x. So 0 of f of x, I'm approaching 0 and 0, so it's going to be 0. Nope. Where is the, yep, 0. This is the x-axis. I lost my x-axis. So it's 0 times 1.3, so it's 0. The top of the next page is D, which is the limit as x approaches -1 of f of x over g of x. So it's going to be approaching -1 of f of x. When you approach -1 of f of x, they're both approaching -1, the left and right. So it's going to be -1 over -1 g of x. From the left it's approaching 0, from the right it's approaching 0, so it approaches 0. So -1 divided by 0 is undefined. E is the limit as x approaches 2 of x cubed times 5x. So we can take that x cubed out, but when you take the x cubed out, what is the value of x? 2. So we're going to get 2 cubed out here. The limit as x approaches 2 of f of x. 2 cubed is 8 times, when I approach 2 on f of x, when I approach 2 on f of x, I'm approaching 2. So it's 16. And then f, we have the limit as x approaches 1, the square root of 3 plus f of x. So technically I have the square root of 3 plus the limit as x approaches 1 of f of x. And so it's the square root of 3 plus 1, because the limit is f of x approaches 1 of f of x. From the left and from the right it approaches 1. So it equals the square root of 4, which is 2. I'll give you a couple questions out of your textbook and then we're going to move on.
Why? How do you get this 2 cubed?
Because it's x cubed, and x for this question, 2 is x. So you'd fill in 2 cubed, which would make it be 2 cubed. And any constant I can take out front. So if x was approaching 1, then it would be 1 cubed. You're just doing it right now, and then we're moving on. Now we've looked a lot at graphs to calculate limits, or we did table of values to calculate limits, but there's actual math we can do, algebra, that we can calculate limits as well. So there is this one property called direct substitution property. If f is a polynomial or a rational function, right, so x cubed, x5, or a rational like x plus 1 over x minus 2, something like that, and A is the domain of f, then the limit as x approaches A of f of x equals f of A for a rational expression. So for example, what that's saying is wherever your graph is continuous, so on the domain, it exists in that area. If I ask you for a limit that exists in an area of the domain of a graph that is continuous, the limit will equal the graph itself at point. So let's look at this. Example 1, evaluate the following. If I have 5, and this is a continuous function, it's just a quadratic, right? If I fill in the value of 5 and I get f of 5, whatever that value is, my limit's going to approach on both sides because it's a continuous function. So I can just do direct substitution. I can just fill it in and get an answer. So I'm going to go 2 times 5 squared minus 3 times 5 plus 4. So I get 50, 25 times 2, 50, minus 15 plus 4. And so you should get 39. Yes. It's also the value at f of 5. They're actually the same because the graph is continuous the whole way through and it's continuous at 5. Yeah. We're going to do some math so that it does work. So B, if we take the negative 2 and we fill it in, let's fill it in. We get negative 2 cubed plus 2 times negative 2 squared. Please stop talking. Minus 1. Girls. Minus 5 times 3 times negative 2. 5 minus 3 times negative 2. You're going to get negative 8 plus negative 2 squared is 4 times 2, which is 8, minus 1, over 5 plus 6. So you're technically going to get negative 1 over 11. So from the left and the right, it's approaching negative 1 over 11. Yeah.
Will they ever give us that? And then the top splits up so that we have a point of discontinuity and the limit all on the point of discontinuity.
Yeah. And if that happens, we're going to deal with all the stuff after this. Okay. So not all limits can be evaluated using direct substitution. Actually, most limits cannot be found using direct substitution, which is going to be the rest of these. So we always check for direct substitution first. Some people are like factoring them, trying to get common factors, canceling, doing all these crazy things, and they could have just filled in 1 and gotten the answer. Okay? So the very first thing you should always check is, can I do direct substitution? If I can't, then I do extra steps. So example 2. Yeah. I take a 1, I plug it in, I get a 0 in the denominator. Right. So when you take the limit, if you take the limit, the value of x, and you plug it in, you get a 0 in the denominator, which is an issue. We can't have a 0 in the denominator. So therefore, we can't do direct substitution. If you have a 0 up here and a 0 down here, you still can't do it. The moment you have a 0 in the denominator, we have to do a different method somehow to get rid of that x minus 1. Do you know how we did the x? It was like h plus 3 cubed. And you had to expand it all out, and then you had to take an h out, and then the h is canceled. Remember how we did stuff like that in the review? We did stuff like that because it prepped you for this. So we have x squared minus 1 over x minus 1. So the top is a difference of squares. So that's what we're going to do first. So we have the limit. It equals the limit as x approaches 1. And in the top, we factor it. X plus 1, x minus 1. In the denominator, we have x minus 1. So technically, this graph has a horizontal asymptote going through 1, right? Well, point of discontinuity, going open at 1. You're right. So I have a hole. I have a spot that doesn't exist, correct? I have a spot that doesn't exist. So when we're calculating the limit, we can't just say it is the value at that point, right? Because it doesn't exist. So we're looking at it from the left and the right indirectly by just doing math. Okay? So because it's a point of discontinuity, because these two factors cancel, once those two factors cancel off, our issue is gone. And now we can do direct substitution. So we're going to get 1 plus 1. The moment, I don't know why I put it in brackets. The moment when you can actually substitute in, the limit as x approaches 1 goes away because we don't need that anymore. That's just telling us what to substitute in. The moment we substitute it in, that limit word and the x and the arrow and the 1 go away. We don't need them anymore. Yeah.
So this is just for questions where the left and the right have the same
Yes.
point of discontinuity won't have one direction or it wouldn't have it.
It doesn't have anything at all. There's nothing existing there, right? So the answer is 2. So what's happening is you have a graph that from the left and the right are both approaching 2, but when I hit actually 1, what happens? I have an open circle, right? I have a point of discontinuity. So this graph from both sides is approaching 2, but actually at the value of 1, I have an open dot. I have a point of discontinuity. Okay? Now, let's look at this one. Evaluate the limit as h approaches 0. I can't do this directly. If I put a 0 in, I get a denominator of 0, which is an issue, right? So I have to somehow maybe expand the top in hopes that I can take an h out, cross the h's off, and then I can substitute. Because my whole goal is to get rid of this h, get it to cancel somehow. So if I expand 3 plus h out, you're actually foiling it. A whole bunch of people, I don't know why, I think it's just habit, write 9 plus h squared. That's not 9 plus h squared. That's 3 plus h times 3 plus h. You need a middle term as well, right? So you're going to get 9 plus 3h plus 3h, so plus 6h, plus h squared, minus 9, because the minus 9 just stays there, over h. So you just FOILed out the 3 plus h, right? Now the 9s cancel, which they need to. Because if the 9s don't cancel, I can't take a GCF of h out, and I can't cross the h's off. Okay? So your constants are always going to have to cancel. Yeah. No. Okay. So the 9s cancel, and I'm left with the limit as h goes to 0. And I can take an h out of the top. So I'm left with 6 plus h over h. I just take a GCF of h out. Now the h's cancel. My issue is gone, and I can do direct substitution. So I'm just going to go 6 plus 0, which is 6. Like I said, the moment the h turns into a 0, this goes away. This doesn't exist anymore. If you actually keep it going, people are like, well, I still get the same answer anyways, even if I keep writing the limit. You're actually not correct, though. You're not right. There is no limit anymore. You filled it in. Okay? So the moment you fill that 0 in this step, this goes away. So it equals 6. So on both sides of 0, this graph is approaching 6. All right. Why did I tell you sometimes you actually have to rationalize the numerator, which we've always pushed to you guys, always rationalize denominator, always rationalize denominator, always rationalize denominator. Well, sometimes you have to rationalize the numerator so that we can get this bad boy to go away. We have a t squared. If I plug a 0 in right now, I have a 0 in the denominator, right? Well, it's the only thing I can think to possibly do. Multiply by?
Oh, I was just going to say, take the t squared and
You can't do that. Mm-mm. It's attached. If it was 9t squared, you can make it be a 3t. T squared plus 9 is not t plus 9 or whatever you think it is. No. You can't. Okay. So we have to multiply by the conjugate. So I'm going to multiply by square root t plus 9 plus 3. What did I tell you before? When you multiply by the conjugate, the two that are conjugates of each other, you put together. But the two that are not conjugates of each other, you leave separately. You don't want to distribute this t squared into here. You're trying to get it to go away. It is our issue. Okay? So we're going to leave it separate from this. So we're going to get the limit as t goes to 0. Square root of t squared plus 9 times the square root of t squared plus 9 is just t squared plus 9. Then because they're conjugates, your middle term should cancel. So negative 3 times t squared plus 9 is negative 3 square root t squared plus 9. 3 times square root t squared plus 9 is 3 square root t squared plus 9. They cancel. One's a negative 3 of it, and one's a positive 3. which they should cancel. That's the point of doing the conjugate. And then negative 3 times 3 is negative 9. Over t squared in a separate bracket times square root of t squared plus 9 plus 3 in a separate bracket. Do not put those together. If you put those together, you will never be able to get the conjugate, or get the answer, I mean. You put them together. The 9s cancel. I'm left with a t squared on the top. I'm left with a t squared on the bottom. What can I do? Cross them off. The common error here is people do not leave a 1 in the numerator. When things cancel off, when you cancel things off, you're left with 1s and 1s and 1s, right? So you actually are left with a 1 in the numerator. So you're left with the limit as t goes to 0 of 1 over square root t squared plus 9 plus 3. And then you can now substitute in. So you get 1 over the square root of 0 squared plus 9 plus 3, which is 1 over the square root of 9, which is 3 plus 3. So it's 1/6. Try example 5 and example 6. Example 5, you're going to have to factor. Example 6, you have to expand that. 2 plus h cubed. You're going to have to go 2 plus h times 2 plus h times, yes, you are. Be happy it's not a 4 or 5, okay? You have to expand that out. Or the top, you can factor out a GCF of x, so x minus 4, x and then x minus 4. The bottom, it multiplies to give you negative 4 and adds to give you negative 3, so it's x minus 4, x plus 1. The x minus 4's cancel. Our issue is gone, and we can do direct substitution. So we get 4 over 4 plus 1, which is 4 over 5. This bottom one we have to expand out. So we get the limit as h goes to 0 of 2 plus h times 2 plus h times 2 plus h minus 8 over h. Some people want to tell me it's 8 plus h cubed. Wouldn't that be beautiful? Not the case. You have to expand it out. Okay? So you're going to get, I'm going to FOIL these ones out first. So you're going to get the limit as h goes to 0 of 4 plus 2h plus 2h, so plus 4h, plus h squared times 2 plus h minus 8. And then we're going to get the limit as h goes to 0 of 8 plus 8h plus 2h squared plus 4h plus 4h squared plus h cubed minus 8. You know you're right if the 8 and the 8 cancel, right? They have to go away because you have to be able to pull an h out so that they can cancel off, or you can't do this. So the 8 and the negative 8 cancel, and we're left with the limit as h goes to 0 of h cubed plus 6h squared plus 12h over h. You can take an h out of them by actually pulling the GCF out, or you can just cross one off of each. I'm going to be lazy and do that. And so we're going to get 0 squared plus 6 times 0 plus 12. You're welcome. Well,